Hello, I'm Jonathan Crest from the University of New South Wales, and I'm going to go through one of the calculus tutorial problems from MATH1231. It's going to be Chapter 4, Question 2. And in this question, we have the temperature, the air temperature over some period, and we want to know its average value. Okay, so we're told that the temperature, which is capital T, as a function of little t, is measured in degrees Celsius, and little t is in hours after noon. And the temperature is given by this expression here. It's a quadratic. Capital T of little t is 25 plus 2t minus 1/3 t squared. And we want to find the average temperature between noon and 5 p.m. And because the time is measured in hours after noon, noon will be when t equals 0, and 5 p.m. will be when t equals 5. So before I actually calculate the average temperature, I'll just mention a little bit about what the average temperature actually means. Here I've drawn a graph of the function, and that's should be fairly straightforward because this is just a quadratic. You can see that the leading coefficient is negative, so it's a quadratic with a maximum, and you can work out where that maximum occurs either by calculus or completing the square, and you'll get this blue curve here. So we want to find the average temperature over this time, and what the average value of a function over an interval means, it's asking what constant value would you choose in order to have the same area under the curve in both this picture here, the area under the graph of the original function, and the area under the constant value of the average. Okay, so you can see here perhaps this green area here looks pretty similar to that green area there. We want to find exactly the height we need in order to make this area exactly the same as this. If we know this area, which we can calculate from this function, and it should be the same, and we want it to be the same as this area, we can work out the height by just dividing this area by the width of the base. So let's do that. Okay, so we're going to calculate the average temperature, and that I'll write the divided by the base width first. So that's 1 over 5 minus 0. So that's 5 minus 0 gives you that length. So it's going to be 1/5. And times the area, which is the integral from 0 to 5 of capital T dt. Okay, so 1/5 integral 0 to 5, and we have the expression for the temperature T, which is 25 plus 2t minus 1/3 t squared dt. And we need to integrate this quadratic. So we find an antiderivative, which is 25t plus t squared minus 1/9 of t cubed, and evaluate that at 0 at 5. Subtract off its value at 0. That's just okay. So we need to substitute 5 in here. So 25 times 5 is 125 plus 25 squared, which is 25, minus 1/9 of 25 cubed. So that's 125 over 9, and then we subtract off what we get when we evaluate this at 0. At 0, of course, each of these three terms is 0, so this is 0 plus 0 plus 0. And I worked this out before, so I know this is this fraction here is 245 on 9, which is 27.2 recurring, or 27 2/9. And that is our average value. Okay, so the height over here is 27 2/9, or 27 and 2 recurring, and you can see that seems about right. It's between 25 and 30. And yeah, we've calculated the average temperature of this, the average air temperature between noon and 5 p.m, given this expression for the temperature over that time.